One more useful videos for classes 9 and 10 from Easy Elite English. And this time we are bringing you some typical problems on circles. These select problems will illustrate stepwise logic of thought and application, and once you master these few sums, you will be able to get a command on how to approach any problems on circles. So in order to understand the circles chapter, the approach, the logic, and the confidence follow these few sums, because these are typical of all the sums in the chapter on circles. So here we go with problem 1. Problem number 1. We will just have a limited number of problems, but that will give you an example of how to approach such questions and how to solve such questions. So once you understand these, you will be able to understand or solve any problem. So problem 1. Now, in the figure below, O is a center. This O is a center and AB is a diameter. AC equals BD and angle AOC is 72 degrees. Find angle ABC, angle BAD and angle ABD. So these three things you have to find. These three angles. Now in these problems, we shall make use of very simple concepts. Nothing high-tech, nothing complicated, nothing difficult. Fundamental concepts, basic concepts. That is, angle at center is twice angle at circumference. Angle in semicircle is 90 degrees, or angle in semicircle is right angle. And angles standing on the same chord or on equal chords are equal. If two angles are on the same chord, or if two angles are standing on the chords of same length, equal chords, the angles must be equal. So these are the concepts we are using. Because we have a diameter, we obviously will need angle in semicircle, and once angle in the center AOC is given, so you will need the angle at the circumference. And since two chords equal, AC equals BD, this suggests that you will also need this concept, angles standing on equal chords must be equal. The question itself will give you the suggestion. Now, first of all, the angle ABC at circumference, this angle at the circumference must be half of the angle at the center. So if this is 72 degrees, this must be half of 72, 36 degrees. So one question or one part of the question is solved. Angle ABC is 36 degrees, being half of the angle at the center. Next, now we have already found it to be 36 degrees. Now see that this angle, that is angle ABC, this angle, and this angle, that is BAD, both are standing on equal chords. The angle ABC is standing on the chord AC, and the angle BAD is standing on the chord BD, and we are given that AC equals BD. So if this is 36, then this must also be 36. So this is 36 because it is standing on equal chord. AC and BD are equal. If this is 36, this is 36 because it is half of 72, and this also must be 36. So again, one more thing you have got. Now see here, angle ADB, this is 90 degree. Why? Because AB is a diameter and this is angle in a semicircle. This angle we found to be 36 degree, we already found out. So what must be the third angle? In a triangle, the sum of the angles must be 180 degree. If this is 90, the other two must be 90. So 90 minus this much. So we have got 54 degree. 90 minus 36, so 180 minus 90 and 36 combined. Either you can take one is 90, so the other two together must be 90, so 90 minus 36, or 180, the total angles of triangle, minus this 90 and this 36. So in any way, you are getting 54 degree. That is the answer for part 3. So simple concepts, simple rules, step by step, it is very easy to solve these types of questions. Problem 2. In the given figure, AB is 9 centimeter, PA is 7.5 centimeter, and PC is 5. Chords AD and BC intersect at P. Prove that the triangles are congruent, PAB and PCD. So we are going to make use of angles subtended by a chord. And if the triangles are similar, then sides are proportional. And the ratio of the areas is equal to square of the ratio of sides. The first one, angles subtended by a chord. Angle BAD and BCD, both being subtended by the same chord, they are equal. BAD, this one, we are putting it X. And this one, BCD, this is also X because they are standing on the same chord. And also you have, as we told earlier, see the names of the two angles, only the middle letter would be different. BAD and BCD, only the middle letter would be different. They are angles in the same segment, or angles on the same chord. So they're equal, each being equal to X. Similarly, angle ABC and angle ADC. See, angle ABC and angle ADC. Again, see, only the middle letter is different. B is different. Here D is different, but otherwise A and C are same. So these are also angles in the same segment. So each of them is Y. We put them as Y. Now, this is vertically opposite angle Z. This is vertically opposite angle. So we see that three angles of the triangle PAB and three angles of the triangle PCD are equal. So they must be similar. All the three angles are equal. The sides are not equal, but the angles are equal. So the triangles are similar. So we have proved the first part. Now, since they are equal, the corresponding sides must be, the ratio must be same. The ratio of the corresponding sides must be equal. So take the angles opposite to Z and opposite to Y. Angles opposite to Z, this side is 9 centimeter, and opposite to side, this is BC, which you have to, DC, which you have to find out. 9 centimeter is opposite to Z, and here this CD, which you have to find out, that is opposite to Z, equal to, which one is opposite to Y? Opposite to Y is 7.5, and here opposite to Y is 5. So this ratio must be equal to this ratio, and the sides opposite to Z angle and sides opposite to Y angle must be equal, that equal in ratio. So we get this equal ratio. So we get CD equal to 6 centimeter. One more part is solved. And area should be equal. Either you can take 9 and 6, the 6 we found out, or you can take 7.5 and 5. In whatever you take, that ratio will be 3:2. So if the ratio of the sides be 3:2, the ratio of the areas will be 3 square and 2 square. That is 9:4. The areas will be proportional to the square of the sides. So the ratio of sides 3:2, ratio of areas, the square of that 9:4. So another problem solved. Problem 3. In the given figure, TP and TQ are two tangents to the circle with center O touching at A and C. If angle BCQ is 55, BAP is 60, find these angles. Now we shall make use of these simple concepts, fundamental concepts. radius is perpendicular to tangent, and angle at center is twice angle at circumference. Simple concepts. Radius is perpendicular to tangent at the point of contact, and angle at center is twice angle at circumference. First, see, radius is perpendicular, so the total should be 90. We are marked by white square. This white square indicates 90. And angle BAP is 60 degree given. So the remaining part we get as 30 degree. So the remaining part is 30 degree, and radius OC, again take radius OC is perpendicular to tangent. So this is 90 degree. We are marked by a white circle, and this is given 55. So the remaining angle 90 minus 55, so this must be 35. So we got this angle 30 and this angle 35. Now this is an isosceles triangle because this radius is equal to this radius. The two radii are equal, O and OB. Similarly, in this triangle, this radius and this radius should be equal. So these are isosceles triangle. If this is 30, this must be 30. And if this is 35, this must be 35. So 30 and 35, we have got answer number 1. Because this is 30, so this must be 30. And this is 35, so this must be 35. Because these are radii, all are equal. They are isosceles triangles. So one more part is solved. Next, having found this as 30 and this as 35, the total is 65, angle at the circumference. So angle at the center would be twice, that is twice 65, 130. Angle AOC is the angle at the center, that is double of angle at the circumference. The total is 30 and 35, 65. So twice 65, we are getting 130. So AOC is 130, another part solved. And finally, this is a quadrilateral. 1, 2, 3, and 4. There is a quadrilateral, sir. There is a quadrilateral, and this is a quadrilateral. So this is 90, this is 90, this is 130. The total should be 360 for a quadrilateral. So the remaining angle 360 minus 90 plus 90 plus 130, that is giving you 50 degrees. Or since you can take these two are 90, the other two should be together 90. So if this is 130, this should be 180 minus 130, that is 50 degrees. So this is 50 degrees ATC. The third part is also found out. That was Easy Elite English Educational Trust, bringing you videos for stress-free education for classes 9 and 10. WhatsApp us or email us if you want videos on any specific topic, because all our services are entirely free of charge. Till we meet again, wishing you all good luck. Thank you and goodbye.